could also support mod anti-malware. So let me talk a little bit more about the details, but before I do that, I just want to summarize the high-level benefit here and talk about what the world looked like before mod anti-malware and what the world looks like after mod anti-malware. So without mod anti-malware, what would happen is that a site would get attacked. At some point, it would get discovered by the website owners, but in the meantime, users would unknowingly be getting infected, and even after the website discovers that there's a problem, their technical teams would typically be in a crisis mode. Their senior engineers would have to get pulled off of whatever they're doing, figure out exactly where the infection is on the website, what pages it's impacting, what is the infection on the page, what needs to be eliminated out of the files, what needs to be eliminated out of the database to resolve the problem. And so typically, before the existence of mod anti-malware, it would take some number of days for the bad guys to contain, or for the good guys rather, to contain the attack and remove it. During that entire time, the company running the website could get blacklisted and lose their brand, customers, revenue, etc. With mod anti-malware in place, it significantly shortcuts and streamlines the containment of the infections. And the way that takes place is that when a site gets attacked, the monitoring service, in an automated way, discovers and diagnoses the problem, sends in the model that we saw, sends the report to the security team and or to the webmaster, contains the infection once the approval takes place, and so the containment can take place within a matter of hours or even faster, just depending upon how fast the site is monitored and how fast the security team and or webmaster responds. So the containment can happen now within hours or even faster. And then the interesting thing is that even though the site is still in an infected state, there's infections in the files, infections in the databases, wherever, those infections can be removed without having to be in a panic code red mode where the website is losing its traffic, its revenue, its users, etc. So that's what the world looks like with mod anti-malware. I should also mention that mod anti-malware can be deployed in a model where the approval doesn't necessarily need to take place. We, for instance, at Dascient work with a number of web hosting providers, and some of them have basically said, look, I want you to do the quarantining for me automatically. Just go ahead and automatically deploy the quarantining directives. No user or administrator approval required. And that basically makes the containment work pretty much as fast as the website's being monitored. So that's without mod anti-malware. With anti-malware, let me talk more about the details in the architecture. So mod anti-malware is available both as an Apache or as an IIS module. It's structured as an output filter in both cases. The main function is a function called quarantine filter, and I'll provide a schematic on how quarantine filter works. I should also mention there's two versions of mod anti-malware. There's a standard version and there's a light version. We have made the light version open source. So you can go to SourceForge, type in Dascient, and download the mod anti-malware light module. Or you can come to Dascient.com and download the mod anti-malware light module. When you download it from Dascient.com and sign up, we also will provide some free trial malware monitoring for the website that you're using to try out mod anti-malware light. So please feel free to check that out. In terms of mod anti-malware's architecture, there's a couple key things that characterizes its operation. The first thing that characterizes its operation is a set of handlers that the module supports, where a handler is, of course, a URL at the domain. And there's three handlers: statusz, configz, and topz, and I'll talk a little bit about each of those. And then the second thing that characterizes mod anti-malware is the set of configuration directives that it supports. And I'll also talk about the configuration directives. But let me talk a little bit about each of these handlers first. So basically, if you have a domain like domain.com, then when mod anti-malware gets installed on that domain, the module will respond to requests for domain.com/statusz or domain.com/configz or domain.com/topz. top Z. And each of these handlers does something different. So what status Z will do is it will echo what is the last set of configuration directives that was sent to mod anti-malware. Configz will allow the requester to send configuration directives to mod anti-malware. Top Z will echo what are the most frequently accessed URLs at domain.com. And the reason for that is because you want to make sure that you're monitoring the most popular URLs most frequently. Because very often when the attackers spread web-based malware, they have a strong incentive to affect those pages that are most popularly used, because that will give them the largest footprint in terms of infecting users. So I talked a little bit about the handlers. Let me chat a little bit about the configuration directives. So there's 4 configuration directives that I'll talk about here. Mod anti-malware supports more configuration directives, of course. But the first one that I want to talk about is a directive called Daswani shared auth key. So you could imagine that you only want certain authorized parties to be sending configuration directives to your mod anti-malware module. You don't want people reconfiguring your web server or stripping out legitimate elements on the page. So that's what the Daswani shared auth key does. Is it allows the webmaster to specify what is the shared authentication key that should be used when the caller, the monitoring service, authenticates to the web server. So that's one configuration directives. Mod anti-malware Lite as well as mod anti-malware support a second configuration directive, which is called set blacklist redirect message. So I talked about mod anti-malware, the premium version, and I talked about mod anti-malware Lite. The key distinction with mod anti-malware Lite is that in the case that a web page gets infected, what mod anti-malware Lite will do is it won't strip out the just the malicious piece of code that's infected, but instead will serve a message of the webmaster's choice and block the entire page from going out. So the idea there is that when mod anti-malware Lite is used to contain a web-based malware infection, then if a website gets infected, then instead of the user seeing the red screen of death from the browser or seeing the other types of messages, the webmaster can choose a message like, this server is experiencing technical difficulties, please come back later, or whatever HTML web page that the webmaster would choose to be served to users, so that even if parts of their site are infected, the rest of the website can continue to be used. And for those web pages that did get infected, the user sees a much less scarier message than otherwise. So the set blacklist redirect message configuration directive does exactly that. The next configuration directive that's supported by mod anti-malware Lite is blacklist redirect URL prefix, and basically it specifies a prefix of URLs for which the regular infected page should not be served, and instead the blacklist redirect message should be served. So in this particular case, it's saying that foo1.html, instead of serving that page, serve the blacklist redirect message. Now, blacklist redirect URL prefix is an example of a quarantining directive, and mod anti-malware supports a number of different quarantining directives, but this redirect message is just one of them. There's other messages that would, for instance, be able to quarantine a particular path in an HTML DOM if that particular path is where the infection is. And there's a number of other mechanisms. The final directive that I'll talk about is a directive called remote directives file, and it basically specifies what is the file on the web server into which all of these directives should be stored. So that's what that particular directive does. I mentioned that there's quarantining directives. There's two kinds. The kind supported by mod anti-malware Lite supports the blocking of infected pages from being served to users, and the full version supports filtering of the malicious code from being served to users. So those are the two kinds of directives. I figured it might be useful to illustrate what happens when a authenticated request is made to any of the handlers. So by the way, all of the handlers require the Daswani shared authentication key to be specified. The request must take place over SSL, it's got to be a post, etc. And so when you make a authenticated request to status Z, what you'll get back is data like this. You'll get back the process ID of the web server process that served it, what its parent was, what was the last time that configuration data was sent, what was the configuration data that was sent, and some data about what are the current configuration directives that are being used by the module. So that's an example of what comes up in statusz. In this particular case, redirection for the foo1.html page is being enabled and the technical difficulties message is being shown. So that's the statusz call. The next call is configz. It will basically, once it gets called with new configuration directives, it'll output what was the configuration data before the change in configuration data and what was the configuration data after, and it will give the caller a message to let them know whether or not the new directives specified in the configz request were actually sent to the file. So basically, there's two updates that happen when configz occurs. The first update that occurs is that in the web server process that receives the request, it will update the directives that are used in memory. It will also write those directives to disk, and the memory that it uses is shared across the web server processes. So the new configuration directives will be propagated to all the different web server processes. Well, that's configz. And then topz, if you make a request to topz, it must also be authenticated. You don't necessarily want the rest of the world to know what your most popular pages are. It'll give the process ID, and it'll give all of the URLs and the number of times that those URLs have been requested. Basically, it uses a bounded hash table to store the topmost requests. So that's those are the handlers. In real life, and I thought it might be useful to just kind of walk through the main loop of the quarantine filter function, which is at the heart of the module. The first thing that happens whenever any request is made to the web server and the mod anti-malware module is invoked is it will update the bounded hash table that is responsible for responding to the topz request. It will then, for each URL prefix that there exists quarantining directives for, it'll check. Or actually, I'm sorry, I'm talking about the mod anti-malware light architecture here. So it'll look for each URL prefix for which there's a blacklist URL prefix directive, and will check whether or not the URL being accessed is for that URL, and if it is, it will basically serve the redirect message and will construct a completely new bucket brigade. For those of you that are familiar with Apache and its architecture for modules, it keeps a passive set of buckets that go through processes. And we'll construct a bucket brigade with the blacklist redirect message and serve that. If not, if we shouldn't do a redirect, the one other thing that it'll do is it will send a HTTP response header called xquarantined1. And the reason that's important is because what the monitoring service does as one of its value adds is after quarantining directives have been sent, it will verify whether or not all of those quarantining directives have successfully went into effect and malware is no longer being served by the website. So the monitoring service can use the xquarantine directive to figure out for a particular URL, is the module doing something? If the module is doing something, and for instance, the page is no longer infected, then you're in good shape. The infection has been contained. On the other hand, if the module is doing something and serves the xquarantining directive and the malware is still coming down, then basically the monitoring service can send a upgraded quarantining directive. And actually, we have a white paper describing mod anti-malware and all these details. You can check it out on the Black Hat CD. But in any case, if you don't need to do a redirect, then you just go through the standard set of Apache functions to then take the output filter out of the loop and pass the brigade of content to the next module. So another couple interesting things about the implementation. I mentioned authentication. This is a screenshot of the configuration that we have at Daswani.com for a particular mod anti-malware module. You see that when a domain is added for monitoring, it provides a Daswani short authentication key. It reports on whether or not the module is enabled. And basically, once somebody enters this particular screen, the monitoring service places a status Z request to ask the module, hey, are you okay? Are you operational? Are things good? And that's why we get back an OK message. So authentication is a interesting part of the implementation. Quarantining verification, I also mentioned, is an interesting part of the implementation.